Okay, students, welcome to Easy BTech, your guide for BTech and beyond. Today's topic is how the BJT can operate in a breakdown region. Now, what are the breakdown voltage in an BJT? Remember here, basically, breakdown can occur when a device is operated in reverse bias. These breakdowns are of two types. One is a avalanche multiplication or avalanche breakdown, and the second one is punch through or reach through effect. Punch through or reach through, that we will discuss in detail. Okay, students, breakdown mechanism. Breakdown mechanism. Generally, breakdown occurs in the reverse bias. Generally, breakdown occurs in the reverse bias. Okay, in the previous section we have studied when base to collector junction, base to collector junction, base to collector, that we represented as a JC. When JC junction is operated in reverse bias, then the width of the depletion region, changes, width of the depletion changes occurs. Okay, these are the effects. It means when you are applying the reverse voltage, the width of the depletion region changes can occur. Now, there are two types of voltages are there that we will call as the VCB increases. As VCB voltage increases, then the factor we can clearly see, one is an early effect, second one is punch through, or reach through effect. You will see these two parameters here very clear. Due to this, VCB voltage increases. Now basically, now you can see it is polarities. Now the transistor is operated in active region. Can make this open. already we know this is an emitter junction, this junction is emitter junction, this is an collector junction, this is an emitter, this is a base, it is a collector, and you are using the transistor PNP transistor. Now you can clearly see for N positive and P negative, it means it is operated in reverse bias. It is operated in reverse bias. Now when JC junction is operated in reverse bias, what happens? Now it is operated in reverse bias. Now it is width. Now all the electrons are attracted toward this positive and all the holes are attracted toward this negative. The width of the depletion region increases. The width of the depletion region increases as reverse bias voltage increases, that is VCB increases, as reverse bias voltage, that is VCB increases, the depletion region width increases. Now you can say as base is lightly doped, compared to the collector terminal, the depletion region width penetrates deeper inside the base width. The effective base width reduces. Reducing the base width by increasing VCB voltage, is known as early effect. Generally, or the other name of early effect is base width modulation. This emitter, base, collector. Now this is an effective base width. Now here you are giving PNP, it is giving a positive and here giving a negative here. Now we can say this voltage is VCB voltage across JC junction. Now as VCB increases, now you can say, now depletion region. Now remember, if diode is heavily doped, means doping concentration is inversely proportional to the width expansion. Doping concentration is inversely proportional to the width expansion. Suppose already we have seen here. Now it is a junction, it is a P material and it is an N material. Now if P is heavily doped, N is lightly doped, then the width expansion, the depletion region width expansion is like this. Because N region is, this is an N region, as N is lightly doped, more width expansion. As P is heavily doped, width expansion is very less. And as you compare to here in this case, base is lightly doped, collector is heavily doped. Collector is moderate doped as compared to the emitter, but it is heavily doped compared to the base. Okay, now the width expansion is in this manner. Up to here, that is the width expansion. This side is. Now you can see. Now this is the width expansion in collector side. Width expansion. Now this is the width expansion in the base side. As depletion region increases, effective base width, what happens now? The total base width, you can see, now from this point to this point, this is the base width, effective base width, means total base width. Now due to this expansion from this, you are having only the base width is decreased now. It is only the effective base width. This is the effective base width. Now the base width is decreased as the depletion region increases. Base width decreases. This is known as early effect or base width modulation. Okay. Now already what happens as reverse, we know that as reverse bias voltage increases, minority carrier increases, carrier concentration increases, minority carrier concentration increases, which leads to increase the kinetic energy of charges, charge carriers. Kinetic energy of charge carrier increases, due to which more collisions, heat is produced. Okay. Next, avalanche multiplication takes place. Avalanche multiplication takes place. It is same as the reverse bias voltage increases, the minority carrier concentration increases. Due to increasing the minority carrier, as further reverse bias voltage increases, this minority carrier have a tendency for more energy, more kinetic energy for that minority carrier increases. Then it can hit the covalent bond. The covalent bond can breaks like that. It can break more and more covalent bonds, and more and more free electron hole pair creation can be takes place. Due to hitting a collision, a larger amount of heat is produced. And the damages of the circuit may be takes place. This is known as an avalanche effect. Okay, start. And the effective base width is reduced. The effective base width is also reduced. This multiplication factor we can remember in this manner. That is how we can represent this multiplication factor. That is M avalanche multiplication is equal to 1 by 1 minus applied voltage VCB into beta VCB naught whole power n. This is an avalanche multiplication factor. M is the avalanche multiplication. As reverse bias voltage increases, more amount of minority carrier concentration will produce, due to which kinetic energy of minority carrier increases, more amount of collision takes place, which leads for the damage of the transistor can be takes place. This is a avalanche multiplication process. Now, similarly, if you go through the punch through effect or reach through effect. Now, similarly, it is emitter, it is base, it is emitter. This we will call as a it is base, it is collector. Now you can see, now this negative, positive, if it is NP, PNP, they are giving negative here. Then it is operated in reverse bias. As reverse bias voltage VCB increases further. As reverse bias voltage increases further, strong enough means larger, strong enough, then the base width then the base width is totally occupied. The base width is totally occupied by the depletion region. The base width is totally occupied by the depletion region. There is no base. There is no base between emitter to collector. No base between emitter to collector. What happens, you can see here. As this reverse bias voltage further increases, what happens? Already the width, the previous session we see, in the early effect, as the reverse bias voltage increase, you will get it is the effective base width. There is a width expansion. Now as this reverse bias voltage is increased further, then automatically total base width, this total base width is occupied by the depletion region. From here to here, we will call this region is a depletion region. This region is a depletion region. Due to which what happens? Now here P, here P, here P. Then the circuit will become short circuit. The transistor will become short circuit. A huge amount of current flow, a huge amount of current flows through the transistor. A huge amount of current flows through the transistor, or the transistor damage takes place. Okay. Either we have two cases. One, first case is as the reverse bias voltage increases further, effective base width modulation takes place. Some of the base width is covered by the depletion region. Now as you increase the reverse bias voltage further strong enough, then the width of the depletion region, is totally covered. The width of the depletion region is totally covered with the width of the base region is totally covered with the depletion region. Now the self-destruction means the transistor gets damages. Okay, now what happens? What is the consequences? Consequences of increasing the reverse bias voltage. Consequences of increasing the reverse bias voltage. The first one is alpha increases. Okay, now what you can say, if VCB increases, reverse bias voltage increases, what happens? Effective base width decreases. Then number of holes and electrons recombination takes place inside the base. Then automatically this beta increases, definitely alpha increases. That is, if alpha increases between 0.992 to 992. Now similarly the beta will increase from 99 to 124. It means for a small increasing of alpha, there is a large increasing in beta. Okay, that is a factor. Next, this is one of the important factor. Okay, students. Okay, students. In the today's lecture, we discussed what are the multiplication, what are the avalanche multiplication, and what are the breakdown mechanisms that we have studied.